Hi, I'm Albert. This is Hallicrafters Rehabs, and welcome back. And as while we're still in jail, things I think are getting better. There's even some indication that things weren't as bad as we thought they were. But we know that God causes all things to work for the good of those who love Him and are called according to His purposes. And I'm an optimist. I think we'll be out of this pretty soon. So my last video ended rather abruptly when I was disappointed at the output transformer results. I've had good results on 3 restorations of an SX-99 and 2 99s, and in all cases there was no problems with the output transformer, and then until we got to this one. So I've got a generic replacement on order, and I have a spare from a S85, and when that comes in another video, we'll go through all that and take a look and see what the options are. But we'll get this thing working well. So for today's work is it's not work, it's play. But we're going to be doing and I'm going to turn this light out because it actually makes it easier to see. We're going to do the IF alignment. And with a spectrum analyzer, and then I think there'll be time for it. We'll take a look at doing it. This is actually on sweep right now, and we will actually take a look at how you would go about using an oscilloscope if you didn't have a spectrum analyzer. In fact, I have an SX-100 that was aligned with an oscilloscope. Not quite as good because you can't see what you're seeing here, which is, let's get this up a little bit. Okay. And we'll change this display line up a little bit. Okay, the units are not important. For the most part, spectrum analyzers are relative measurements. So let's go back to frequency. And step 1 is to actually find the in place or wired in crystal frequency with all its parts and everything and wires hanging off of it. Makes it a little bit different. But the way you do that is, we'll turn sweep off, and I've got it on sharp. Band 2 is what they want you to do. I have the input. What I've done is I've got signal generator input is right here. It's actually an oscillator input into the converter. Normally used to do just the body of that resistor, but for some reason I can't get enough. Maybe on this one I don't have enough signal to work with, and it doesn't seem to bother what we're doing here. The pickup is at the detector, which is right off of pin 1 of T3, which goes in here. So that's the plan. And when you're doing I'll make this we'll go to frequency on here, and I'll make this okay, I just turned it 8, okay, and the signal amplitude goes down when you go away from the crystal frequency, and then 7, and then 6, see how sensitive that is. Then when you go down a digit, okay, I'm at 457, I'm going to go up 1, and I'm going to go down 1, and see there? And then you go up a digit. You go up 1, it's not as much. That's telling me I didn't quite have it. 457.007, and okay, we'll say 457.1. So what I'm going to do is record that, and I will write that down. I thought I wrote down what I measured when it was outside the set somewhere, but in the set, wired in, is 457.101. 457.01. Now, that's not where it should be. It should be 455. And there's techniques for what they call shaving the crystal and stuff like that. Never done that before. Don't have a long pile of crystals to play with. They're hard to find, rare. You know, a set sacrifices one to give one. So it's 457, and that's where we're going to leave it. So we'll turn sweep back on. And so that's where the alignment will center. Now, I've still got it on sharp. If you look at broad, it's the same, essentially. That's the way it should be. But when you go to normal, the crystal's out of the system, and you see that the little mountains. There's a mountain peak from one of the IF, and there's another one, and there are three. So they're not together. So the tops are the primaries, and I've got it back on the Lazy Susan. Isn't that nice? Oh, it works so good. So we're going to first start with the primary of T1 and see where that goes. Looky there. Now it starts going down. Very sensitive. Alright, let's go to the secondary of T1. There we go. So our issue is somewhere else. I found all my alignment stuff here. No problems now. No issues. No worries, mate, for my friend down in Australia. Okay. So now we're doing an adjustment of the primary of T2, just to see where it goes. It's only got one limit, it can't go any further there. Wants to go towards 455, see? Alright, that seems to be in the middle, but I think our secondary is not in a good place. This can be the first of many hours of this, okay? Oh, looky there. We're getting pretty sharp, but we're on the top side now, so we'll have to come back through again. We're above 457. But the shape is looking better. There's something, it's like it's at the limit of travel in both directions. Let's see what happens here. We don't like that. Okay. I wish if I blow it up, it gets blurry. Then this cheap Chinese There we go. Let's pull it over this way. There we are. It's nowhere near the limit of its travel. Shot on this side. This I'm on T3 right now. Getting off center. That one there is at the center, at the marker. I'm sorry, the marker is at 457.43, so the center frequency should be there too. 457. Marker. Yeah, that's what we're trying to do, is we're trying to align it to the crystal. So it won't be 455 when that happens. Alright, let's see if we can get this a little bit more. T3, primary. Primary at the top, secondary at this bottom. At least for these Hallicrafters that I have. Alright. So now we'll try again with T1. Really wants to be. There we are. It was off. It was off frequency. Okay. Alright, that's a normal. There's sharp, a medium, and then there's sharp. That's the way it should perform, okay? Well, we got some others that are not where they need to be, so let's see how we can fix that. So I'm at the primary of T2. It's in normal. Now we're in secondary of T2. Oh yeah. Just racking in those decibels here. Primary of T3. See, yeah. There's no more travel in that direction. It doesn't want to travel. Let's see if I can do it this side. This is the middle side. Very dangerous. Secondary side of T3 without causing a spark. Use improvement. See, we're getting it there, getting somewhere. Now, the marker has moved. That would tell me that if I go to crystal, it's going to shift a little bit. And guess what? They do. It's actually operating the way it's supposed to, that one. Don't have a notch yet. We'll go to the deal with the notch thing later. Okay, let's give the start again on primary T1 down in broad. Very sensitive. And this is your reference for the whole IF chain, primary of T1. And we'll come around and do the secondary of T1. And we're going to get that. We're not getting peak. There we go. Somebody else is out of a line, not the secondary. Okay, so we'll try primary of T2. One of these characters is offline, out of line. That's actually going in the right direction. I think what we were looking at is the peak of T2 coming out under there. Let's try the peak of T3 right now. No. Let's try to get this hump out of here. Well, after another 45 minutes of standing or something like that, it's where it needs to be. In normal, we have a bandwidth of about 5 kilohertz. Now I use a -3 dB for my measurements, not -6. Long story. So 4.70 in broad. Then we have to change the scale to see the notch. That's what it looks like with the 6 dB scale. Alright, you bring it into broad, and there's your notch. Very nice. And then there's a no notch position, essentially. And the narrow bandwidth is about 3 dB. 3.2 or something. I mean, not the broad is about 3.2. The narrow is about the same. So possibly because the crystal's a little bit off, that might be the reason. But for whatever reason, let's do the frequency, center frequency, and let's do the marker, normal at the center. So at sharp, 457, broad, 457, and then normal, just a little bit down frequency, which is the way they normally behave, 455.6. Actually, this has been the easiest ever, and still it takes a lot to get a lot of adjustment. I could sit there and try and tell you one versus another, but then I'm moving around so much I forget what's what. So you just you're basically setting the primaries to the on frequency and the secondaries to get the shape that you're looking at. That's a broad way of looking at it. Okay, so now we're going to set up for what the scope would look like. And we'll come back after I get all that done. We're done. I'm going to actually take pictures, snap screenshots in each position to save and put in my my alignment report. So I'll do that first, and then we'll come back. Okay, I saved everything on my screenshots, and now what you're looking at is a sweep of the frequency generator through the RF, and it's picking off in exactly the same point off the T3 to the detector. And to get this picture, you need about 1/10 of a millisecond. I don't think it makes any difference between that's log versus linear. Makes it easier to see. And this is just another way. All you're looking for when you're the shape is not really going to change. I don't know. It's been a long time. I really don't want to mess with the alignment that I have right now off the spectrum analyzer, but it's a bit like just looking for the maximum response. It'd be the same as if you were using a voltmeter on on the speaker terminals, but it's just another way to look at it, and it gives you an idea of the shape of the curve. Now, I couldn't tell you if there's any meaning to this or that sort of thing, but it took a lot of playing to get to see this, but about 1/10 of a millisecond synchronized on channel 1. I've got about 220 hertz is my sweep rate, and it's enough voltage set per division to see the picture. So that's what it looks like when you're sweeping through the oscilloscope. It's another way. I could have done this when I was doing my signal tracing, and I would have seen it might have been an interesting thing to do at that point. But now I'm beyond this. I really don't want to go back to this level of this is not the picture that you see on the spectrum analyzer, and this scope isn't frequency calibrated either. I don't know, maybe the cursor might figure something out, but I've read enough instructions to make it work. It's not very sophisticated. So that's what that's another way to do an IF alignment. So in the next video, either I'll have that output transformer here, and we can look at that, or we'll go on to the RF alignment. Now I want to see if this radio hears anything. That's always the final test. So let me get that set up. Okay. Yes, it does hear something. It's not where it will be when I'm finished with it. It's not had a RF alignment yet. But the IFs are good, and it had a good response. So this is good for the day, and we'll be looking at doing the RF next time, and really appreciate those who are following along, and the subscribers as well. And just remember that we'll all be free soon. This is Hallicrafters Rehabs. Thanks for watching.